welcome everyone, and thank you for joining us today. We are really happy to have you here for this webinar on how to manage Icinga with Ansible. And I would like to start with a few words on Icinga. For those of you who are newer to the ecosystem, just very quickly, Icinga is a powerful open source monitoring solution built for enterprises of all sizes, from small teams to large scale, very complex IT infrastructures. We are headquartered in Germany. Icinga is fully open source, super flexible, and trusted by plenty of IT teams around the world to monitor their servers, networks, cloud environments, hybrid environments, and also Kubernetes clusters. Today's webinar is a very good example of how Icinga community comes together. This time we are partnering with a company who knows this ecosystem very well. So what is today's webinar about? Managing Icinga with Ansible. Why are we here today? If you have ever managed an Icinga deployment by hand, you probably know how quickly things can get very complex. Keeping installations consistent, handling configuration drifts, handling human errors, scaling to multiple nodes. It's a lot of maintenance that you have to do manually, and this is exactly where Ansible comes in. Today, we're going to walk you through how to use the Ansible collection for Icinga to fully automate your Icinga infrastructure. Be it from a fresh installation, throughout to the configuration master instance, deploying monitoring agents, integrating components like Icinga Web, independently if you're starting from scratch or looking to bring consistency to an existing setup. Our goal today is to give you a practical, reusable patterns that you can take back and use right away. Said that, that brings me to our partner for today's webinar, which is NETWAYS. NETWAYS is a leading open source specialist based in Germany. They offer consulting, training, support, managed services, web services across a broad range of open source technologies, including Icinga, but not limited to. They also offer these services for Grafana, Elasticsearch, Ansible, Kubernetes, and many more open source tools. When it comes to the intersection of Icinga and Ansible, NETWAYS are basically the experts because they are the creators and maintainers of the Ansible collection for Icinga, the very collection we will be working today with. After they played a leading role in developing and maintaining this collection for years, we now officially moved it to the NETWAYS namespace on GitHub and also on the Ansible Galaxy. We will also share the link to the Ansible collection afterwards, so you have it to start working with it. In short, if there's anyone you want to walking you through how to automate Icinga with Ansible, it's probably the people from NETWAYS who are building these tools. Very quickly, who are we? My name is Blarim. I'm the COO of Icinga. I will guide you through this webinar. My partner in crime today is Matthias from NETWAYS. He's a consultant and one of the core contributors of the Ansible collection for Icinga. Matthias has the hands-on implementation experience, so you are in great hands today. All right, and that's all from me already for the intro. I'm handing over to Matthias. Let's get started.
All right, just let me share and tell me if it's good.
Looks good to me.
All right. Thanks for the introduction, first of all. And second of all, thanks for also introducing NETWAYS in this broad way, because I don't really have that much slides on me for that. I work at NETWAYS as a consultant, and I work with Icinga mostly when it comes to monitoring, also in my home lab. I'm a huge fan of Ansible, so those two tools basically just had to match in some way. And at NETWAYS, there was already some Ansible stuff for Icinga when I started here. So I just kind of took over as soon as I got to know Ansible and got to know Icinga. So yeah, basically I'm working on the collection ever since I got to know it. On GitHub, I go by Donien. I don't want anyone who's not a German to be able to pronounce it. I don't expect that. If you see this, the upside down me, that's me on GitHub, if you happen to come across my profile. On the agenda for today, I have basically a lot of slides. I kind of overdid it a little bit. But that's also the reason you get the slides in the end and you can download it afterwards. Basically, what I want to do is I want to install Icinga 2. I want to have a master instance and also a secondary master. So we have HA. I want to integrate a satellite, and I also want to integrate agents as well. That's all good and fine, but we also need Icinga DB. So we have a backend and we need Icinga Web plus Icinga DB Web to actually be able to see anything. So we will basically go over the whole stack in one fell swoop. And also I want to talk a bit about structuring an Ansible inventory, because that's often a part that people tend to have problems with. Just a little introduction about Ansible. I think most people know Ansible at least well enough so they can follow along. And apart from that, I just want to say it's config management, it's agentless. Agentless in the case of Ansible basically means we use the board tools on the given systems, meaning SSH and WinRM. This whole thing is push-based. We don't have any central server that agents pull from, but we just push our configuration whenever we want to. The tool is written in Python mostly, and the configuration we do as we interact with Ansible is mostly written in YAML. Also, a big thing about Ansible, don't reinvent the wheel. Please just use code of other people. Other people made had thoughts about things and tried things and made roles. And roles are basically functions you can call. You can give it input by passing variables. And this way you can take a lot of work away from yourself and use what other people bring to the table. Which also brings us to the aforementioned repository, to the Ansible Collection Icinga by NETWAYS right now. We have a few roles for Icinga 2, for example, Icinga DB, Icinga Web, also for Icinga for Windows, and a few other roles. I don't want to list everything. You can just go to GitHub and search for that if you want to see all of it. In my setup today, I have two master instances, two Icinga masters. I have a satellite, I have two Linux agents and one Windows agent, just to show off everything a little bit. And we got a mix of Debian systems and CentOS systems just to basically show that it works. And I also prepared some Ansible groups, namely masters, satellites, the agents, which are again divided by master agents, so the agents that will talk to the master directly, and the satellite agents that will talk to the satellite. And also I got groups for Linux devices and Windows devices. All right, just a little example here. We have a basic playbook that we can use. We can use it on all our Linux hosts in this case, because we want to add the Icinga repositories. In this case, I just have some secrets hidden away because I don't want to show you my password. This password will be invalidated afterwards anyways, but just to show off basically. All this does is include the official Icinga repository so we can install from. Also, another example, just installing Icinga 2, no configuration, no setup, no nothing, just install the package and we are done. We can do with this little playbook, and that's kind of boring, so I will just skip ahead and go into some more details that we need. If we want to create an Icinga master system, we need a few things. We need constants, because the node name constant must match the common name in our certificate. So we should set that and make sure it fits. We also need the mentioned certificate, a CA, and also some features to actually get going. For Icinga constants, we basically just have a variable named Icinga2 constants, in which we can define our constants, and also in addition to the node name, we can set the zone name, and importantly on the primary master, the ticket salt, because the ticket salt will be used later on to create tickets and create certificates from that. Also, Icinga2 features, just another variable. We have a list of different features Icinga offers. These features are basically the same you can see in the docs of Icinga2. You can set the same variables, the same attributes, and they will basically work in the same way. So for most features, you can just copy paste from the official docs, but there's also some features that have additional properties added to it by us. For Ansible specifically, I want to talk about the API feature, because there's a lot of things you might not have seen in the official Icinga documentation. For example, we got this CA host. So this CA host basically means who has the CA, who is my parent, who do I need to talk to if I want to be part of the cluster. If you want to create a primary master, meaning the one that has the CA in the end, then you would want to add CA host none, meaning this one knows, hey, I will just create in CA and be able to act as the master. Also, you can specify the certificate name. You can specify some Icinga2 specific attributes that will be part of the feature. And also in this case, this huge block, basically just a YAML representation of what will end up in our zones conf. So we actually know about the Icinga hierarchy in this part. Meaning you add your endpoints, your zone, you give some relations so everyone knows what zone they belong to, and this will be deployed in the end. All right. Basically, when we got all the variables and run the playbook, then everything will work fine. But the vars, as you can see in a complete example from my setup right now, will basically have all of this, and all of this I want to actually do for a moment. I hope that's big enough right here. I basically want to do everything I just showed you, just in a quick way. And also I want to go to the docs for a moment, if this lets me do it. All right, over on the GitHub repository, you can go to the doc folder, and for every role we have a documentation. And for the Icinga2 role, it's actually a bit bigger because every feature is listed separately. So you can always go in here and just copy paste a few things that you might need. For example, I would just copy the features right here, go back into my playbook, hopefully paste it without issues, and then just indent it correctly. That's the constants, not quite the spot where I wanted to put it. And also I will add Icinga2 constants. I will add the node name, which will be, in this case, my inventory host name, which is the FQDN in my case. And I will add a ticket salt, super secret ticket salt. And then I'm basically done here. I don't need to actually specify the zone. The zone will be part of the etc Icinga2 zones conf. All right, I don't want to force a new certificate, but I want to accept config in the end. So I add that. I also want to accept commands. And now I add my actual hosts. In my case, it's Icinga -master1.nova local, which also has a host attribute with a fixed IP in my case, so I don't have to think about it. And then I basically just copy paste this, change the IP, tell it in what zone it will be, and tell it what nodes will be part of it. So if you are familiar with Icinga itself, that's basically trivial. You've seen this many times. And at this point, I'm basically done with the bare minimum configuration regarding our cluster, so we can actually have a certificate and talk to others. Also, the Director Global, I will add it later in a already solution playbook. I forgot about that, but that's not really important since I won't be using the director right here, right now. What will result from the constants is basically this. We added the node name and the zone name potentially, and also the ticket salt. The other parts are just coming from our defaults, which you can also change if you want to, but there's no need for the plugin directory, for example, because it will just match on the correct system. Also, we get a zones.conf. What I did in YAML right now is basically just what will end up here. As I said, nothing too fancy, nothing unfamiliar to you. Also, our API feature will be activated in this style. The ticket salt will always be set to the ticket salt constant, which in most cases will just be empty. And we also got our checker feature and our main log feature. Which also, what also results from this is our CA certificate and our CA key, as well as our own certificate and our own key, so we can talk to other nodes. If we now want to add the secondary master, we basically just change a few things. We change, first of all, the ticket salt. Our secondary master doesn't really need the ticket salt. And we also change in the API feature the CA host, which will point to our master. So this secondary master will be able to know, hey, I need to talk to this other node in order to be able to get a certificate. So basically a lot of copy pasting and changing slight things. The role itself, the Icinga 2 role, uses tickets generally to get certificates, meaning you need some ticket salt on your master. The tickets are created from the ticket salt and the common name you want to get a certificate for. And Ansible in the role will actually delegate the ticket creation to this CA host we've just seen. And that means we go over from our agent, for example, and then go over to the master system. I turned kind of blue right there. Okay. We go over to the master system, do the ticket creation over there because the ticket salt is available on that system, and then just use that for the next steps to create the certificate. If you don't have access to the master system itself, because you don't always get to play with Ansible on every host, you can actually also just pass the ticket salt itself. If you know the secret, you can pass the ticket salt down here in the API feature, and then you don't need to actually delegate to the master. You don't need a connection from Ansible to the master. And also you need to add this Icinga 2 delegate host. You can set it to inventory hostname, which basically means, hey, run this locally on the host you're currently working with. Basically, you stay on the agent. If the agent knows the ticket salt, the command will still work because the command we run is just Icinga 2 PKI ticket and then the certificate name and the salt. It doesn't matter where you run this command, it will just work. Okay. For now, just the first little demonstration, and I pray to the demo gods that everything works. I basically want to add repositories to run my master setup for the primary and for the secondary master. Just to show you, there's nothing fancy, just a few variables. Also in my master setup, nothing fancy. I would just run that for a moment. And this is the point where I always get and go and grab a coffee because this can take a while. Everyone who works with Ansible knows that there's a lot of downtime when you just wait for stuff to finally work and you hope there's nothing red on your screen. That's the same thing. So I kind of have to talk over this. But just one slide ahead. next we will show it. Go to Icinga DB and have a look at that. But first, let's just enjoy waiting for Ansible to finish its job.
While we are waiting for this to finish, maybe we can even answer one of the questions that was raised. Can the endpoints be retrieved from the Ansible inventory?
If you put it in the inventory in some way, yes, you can get it from there, and it doesn't matter where you actually define the variable. You don't need to define the variable on your play level. You can define it in your host variables. That works fine.
Right, perfect. Yeah, I think that should answer the question. We can also see in the meantime that while waiting, Matthias turned blue. Oh no, now he's normal again. All right, that's it for now, I guess. Thank you.
Yeah. As I said, there's nothing fancy going on. We are just creating our two master systems. I believe it will work, so I will just continue on because I got, as I said, way too many slides and I want to at least show you most of it. When it comes to Icinga DB, which we need on our masters, it's pretty trivial. We just kind of define a few IP addresses on which we will listen for incoming traffic. In our case, for the primary master with the 101 at the end, we just add the IP so we can actually talk to it. We add some secret, which is definitely not easy to guess. And also we have some database connection information that we need to set. In my case, obviously that's a demo setup. The password is bad. Don't use passwords like that, but just to show you right here. Also, we can tell our role to actually import the database schema, which is not a problem. When you have multiple Icinga DB instances, for example, one master and a secondary master, you do not want to add the import schema flag to the secondary because only one of them should do it. Otherwise, you could maybe have kind of race conditions, something like that, because both of them try to do the same thing at the same time, and then that's no good. Yeah, basically that's all I have to say about Icinga DB. Pretty trivial. You can also add certificates and secure it if you want to. You just need to go into the docs and search for the correct variables for that. Just having a look at the Ansible playbook, it worked fine. It created everything we need. I would just go into my inventory real quick and grab the IP of my primary master just to check if I can actually access it and if it did what I wanted it to do. Just a quick look at Icinga 2 zones.conf, and we can basically see the primary master is here, the secondary is here, and both of them know that they are in the master zone. All right. Now we actually want to see a bit. We want to see some information. We want to see some monitoring data. That's why we need Icinga DB and Icinga DB Web and Icinga Web. For that, we need Icinga Web as a package, of course. We need some database resources. We need to be able to have a database for Icinga Web itself and also for the connection to Icinga DB to the database. We need an initial user for the Icinga Web so we can actually log in. And we, of course, need to configure Icinga DB Web in order to talk to the Redis instances and also use the API user to do stuff like downtime setting, comments, check now, and so on. For that, we need some more information on the master system. We need some configuration directories that we will use later. We can define them with Icinga 2 config directories and just pass paths relative to etc Icinga 2. So in this case, we can control zones.d master and have a folder for hosts and a folder for services. And if we want to add something in there, we just basically reference that over here in the file of an Icinga 2 object. Icinga 2 objects, we can do most of them in the Ansible collection. So you basically just pass the type, service, host, API user, other object types. pass the file and also the attributes that are necessary or optional for the given object type. So for a host, you would, for example, add the check command as an attribute. In my case, I want to be able to actually put something in the master zone, so they will be synced. And I can do Icinga2 objects and create, for example, a dummy host that I put into zones master host conf, give it some information just to show a little example here. You can also create services and applied services, but it's also stuff you can look up in the documentation. In my case, what I want to do, I want to have a Icinga DB web API user that I will put into apiusers.conf with a super secret password and also with the correct permissions for it to be able to talk to Icinga2. Also relevant, this is on master 1. I put everything into the zone, so the cluster sync will take care of the configuration spreading. So master 2 also has the same API user in the end. Sometimes, though, YAML ain't enough. YAML is an abstraction. We use YAML to basically write Icinga2 DSL, and thus many features are basically missing. You can't really put everything and cram everything into YAML. That's why you can also always pass your own Icinga DSL. You just write your own file, and then you tell it to deploy it on your Icinga host. So feel free to use it if you have some fancy DSL magic that we cannot abstract. For Icinga Web itself, we need a database for Icinga Web. So we have this Icinga Web _DB, and also again the possibility to import the schema, and also down here the possibility to add a default or initial user and an initial user password. If you want to add other resources, for example, for the director or for Icinga DB, we have another variable, Icinga Web 2 resources. You just basically put your resource in here, and this is where some magic happens. We basically have a ini writer for most Icinga Web related stuff, meaning this thing here, this is a section in our resources.ini, and everything beneath it are key value pairs that are basically just written as you give it here, and you don't need to think about it. If there's errors, they will probably just stay and nobody will complain, because we don't force you to actually have specific keys in here. The same thing I just said, abstracted a little bit. We have the database name and then the key value pairs. Also, lists work fine. Lists will just be translated to comma-separated values in here, and you can basically use that in many places for many configuration stuff in Icinga Web. Also, apart from that, we want modules. We need a module for Icinga DB that we need to define. We need to install it. We need to configure it. And all modules that we take care of have a shared key called enabled and a shared key called source. Source must be packaged currently. There's no other option right now. Enabled, obviously, if you want to enable or disable it. And what many modules do, we have often a file name that is basically a key, followed by a section, followed by key value pairs again. You will see it in the next slide, just to show you again. In this case, Icinga DB needs to be configured. We want the config.ini to be written. So this is referring to the config ini. And in there, we have the Icinga DB section in the ini format. And in there, we have a resource key followed by the Icinga DB _DB value. That's basically everything we do. We just take what you give us and put it into ini files. In this case, just the Redis information, we need to connect to the first Redis, also to the second Redis. I don't have much space, so just imagine the second Redis being here. And also the same goes for the command transport, so we can talk to the Icinga2 API. This is where I have my second demo. I will just go for installing Icinga DB now. Icinga DB Web and Icinga Web on the master, and also Icinga DB on the secondary master, which needs to be there as well. I'm on the wrong host. 06 and 07. That's all, yeah. Again, some waiting time. So if we have questions in the meantime, Blarim, feel free to pass them over.
Yes, I think we have one or two that we could answer in the meantime. Just give me a quick second. So there is a question regarding the inventory. One more. So the question is basically if you loop through the inventory hosts. Now the question is if you could suggest something on pointing out the primary master and secondary master. My guess is that the actual question is how to leave them out from the inventory list when you loop over the inventory in order to install the agent, but exclude the masters. That's how I understand it.
I'm still not quite sure if I got it right, but basically you always want some Ansible groups to have a clean working space. You want a Ansible group for your agents. You want an Ansible group for specific zones, for example. You can have agents, Ansible groups based on the operating system. You can just spread it out like this, and in your master agents, for example, you will have a variable that refers to the master zone. And if you run the Ansible playbook to install and configure Icinga 2, you don't pass every host or every group, you just pass the specific group that needs to be done right now. So yeah, you always need to put a little bit of effort in beforehand so you don't have the pain in the end.
Yeah. So in short, basically grouping the Icinga masters and then applying different roles to them. While we wait, I know that some of the questions are already being answered by other participants in the chat, which is super nice, although the chat will not be in the recording. So I'm just going to repeat one of the questions about a local copy of the Icinga repository. So if I'm not able to access packages.icinga.com, I need to mirror it to my local infrastructure. So I need at least one host that is able to reach the internet. What do you see at your customers? What are they using to create those repository mirrors?
For DNF packages, it's I think reposync. I'm not entirely sure. And for everything else, basically Pulp. Pulp can mirror Debian packages, RPM packages, pip Python packages. It can mirror a lot of things, and it's rather easy to set up.
Right. So what also comes into my mind is Red Hat Satellite can do this, I guess, which would be some sort of enterprise solution. Pulp has already been mentioned in the chat in combination with Catello, which is also part of Satellite, I guess. So it's like the open source version of Satellite. And also there are other tools like JFrog. We also do have rsync enabled on our repositories, so you can basically also just do a plain rsync on those repos. That would be another option that comes into my mind. Feel free to move on. Thank you.
Yeah. All right. I would just go over to the inventory again because I can't remember my IP address for this beautiful host. I would just go into the web for a second. And hopefully it is there and hopefully it can log in. Does it try HTTPS? No, it does not. All right, Icinga Web is here and I should be able to log in as the admin. And I can already see a few services and hosts for some reason. Everything who's familiar, I didn't disable conf D, thus there's a lot of stuff here, which is not necessary right now, but it's here. So I will basically just go on and tell you a bit more about the configuration right there. All right. Oh, just another slide before. Okay. We can also add Icinga Web 2 users. So if you want to have your initial bulk of users available right there, you can add them if you don't use LDAP or Active Directory or something like that. And you can just add them here. You can also add your roles to take care of your permissions. You can add roles again in this ini writer style. We have our roles ini basically referenced by this variable. We have a section called watchers, our first role. We can define the users that are part of it, and we can define the permissions that are part of this role, and so on. Looks a bit clunky, but works fine for the most part. Also, what I just said, we didn't disable conf-d. You should disable conf-d. I just wanted to have something right there to show you right away. All right. What we need for the satellite, if we want to add that, we basically just copy-paste again our API feature. We change the API feature on our masters slightly to include the satellite, so they are aware of each other. And this is basically what we need to do. We need to add the satellite to the master variables, also the satellite zone. And what we want to do, we want to disable conf-d on every Icinga host because we don't need that. And importantly, again, on master one only, on our config master, we want to add the satellite zone so we can actually put configuration in there. For Linux agents, the same thing is pretty trivial. We, again, define some Icinga 2 constants. We define some features that we want, basically just the main log and the API feature. And again, just reference the parents. Here, we only need to know about our direct parents and about ourselves. So that's what we add here. Also, again, add global zones as you need them. For Icinga for Windows, on the other hand, we don't have an Icinga 2 role for Windows. We don't have a way to install just Icinga 2. We only have a way to install Icinga for Windows, including Icinga 2, which is also best practice, so should be fine for in most cases. But we have IFW as a role, which installs Icinga for Windows. You can also manage repositories, components. You can manage how Icinga 2 is installed. You can manage the zones conf of this as well. And all you need is just some variables again. You can add global zones. You can again refer to your CA host, so basically meaning who has the CA. You can reference your parent zone, and which is quite nice, I believe, is the Icinga 2 ticket, which we have here. We can basically take our common name that we want, which is our inventory host name, and pipe that into a filter we wrote, which also has a parameter for the ticket sort. If you know that, you can just create your ticket right away with this Ansible plugin, with this filter. And this filter is basically just a Python re-implementation of the same algorithm that Icinga 2 uses, so there's no difference there. And again, you can tell it to refer to your parents, so you actually know with your Windows host, hey, who do I need to talk to? And then you just run the NETWAYS Icinga IFW role. I need to speed up a little bit to get to show you everything. We talked previously about Icinga 2 objects, which was a list. Icinga 2 objects can actually also be a dictionary. This is kind of a clunky design decision in my opinion, but people tend to like it. So we kept it. We didn't want to break anything yet. So basically what you can do, you can define Icinga 2 objects in your host variables and then tell it on what host the configuration should be deployed. Meaning your config for your agent is part of your agent's host variables, while also telling this variable that the actual configuration will be deployed on the master system. You will see it in the next slide. We have some meta information. We have Icinga 2 zone is master, meaning this agent will be deployed in the master zone. And we tell it, hey, we have this host called Icinga master 1. Please deploy the configuration on that host. meaning background Ansible magic, we will delegate over to that host, or rather collect all the variables from different hosts from the whole inventory to create a huge dictionary basically of Icinga 2 objects to add to this instance, to this master one. Meaning this brings us to structuring an inventory. We can actually use directories in Ansible as an inventory source, which allows us to basically have a lot more control and a lot more granularity about what we want to add, what we want to have as variables, where we want to put them. And we can also have a cleaner working space right there. We can have group variables, we can have host variables, and we can have directories underneath those directories with the specific name. In this case, right here, the group name. Lower down, we have the actual host name, and we can put a lot of files in there to spread our configuration. We have variables for Icinga 2, for example, for Icinga Web, and so on, and can just work in a clean environment. A little example what I actually did. I basically have my groups with all is an implicit group always there, with Icinga 2 objects. And I have the same concept for my agents, for example. And basically, in the end, I will merge all of those beautiful variables into one, so we can actually deploy it. Okay, now for the group variables, we basically have in our satellite agents a meta information, what zone we will be part of. So we don't have to write it 20 times for 20 hosts. We just have to write it once for one Ansible group, and then refer to that later on. Also, the same goes for the Icinga 2 constants and Icinga 2 features. We can just put it in there, write it once, and it will work for all our satellite agents. Example for the host variables, we also want to have some address we can actually check with Icinga 2. So we have this meta information per host. And lower down here in the host variables for Icinga agent Linux 2, we actually want to have some Icinga 2 objects deployed on the master that are specific for this Linux 2 agent, meaning we just have a variable slightly called differently and just add a service. We want to check updates with apt, and that will be later merged. Also in our agents, in our group variables, we have agents underscore Icinga 2 objects, again, something we will merge later. And all our agents in this case will have an endpoint object. They will have a zone object. And in this case, I also added an Icinga 2 service check. So we check if Icinga is running, and we can just write it once and it will be deployed for every single agent. Also, what we have is a generic Icinga 2 objects. Same game again. In this case, we always want a host, but our host isn't necessarily also an agent, so just the host object. And lower down here, this looks a bit clunky. This is just a recursive dictionary combination. We combine the generic Icinga 2 objects up here with our agent-specific Icinga 2 objects, and also combine it with our individual Icinga 2 objects on a per host basis. This results in a huge dictionary, which is great for us because we didn't have to merge it ourselves. We just have to write a little bit of code right here, a little bit of ginger. And this is where I say thank you so far, but I still want to actually do it and show you. So I will go over here. I have a structured version of the same project right here, and I will just show you my inventory real quick. I basically define all my hosts and my connections to the hosts in one file. Also, all my groups are down here. I just have multiple groups and add the hosts accordingly. And after that, I have my group vars over here. For example, my satellite agents. I have my Icinga 2 over here, all my constants, all my features that I need on my satellite agents. And also, they will all know that I have to connect to the satellite. Same game over on the master agents, for example, just with the changed parents. which is both of my master hosts. Some of you might already have seen this IFW. This is for Icinga for Windows, of course. And now the moment of truth, my last demo right here. I have my 0.1 infrastructure, meaning my masters. I got my Linux agents and my Windows agents. And then I will just hope this runs through. Also, another time for questions so far. I'm done after that, though.
That's the perfect timing, actually. I think we also do have a couple of minutes left that we could use for questions. So if something is unclear to you, if you want to know something specific regarding Icinga and Ansible in combination, this might be the perfect time to ask your questions. One of those who already submitted a question is about keeping Icinga up to date. So if I'm using Ansible to install Icinga, I will get the latest version installed by default. And is there a way how I can manage my updates of the Icinga installation package, or is it recommended to use something different that interacts with the package manager?
We don't actually want to do the version pinning in any way in the collection, because that's a huge burden and it's also error prone. We basically just always install the latest version. If nothing is installed, basically just state present for everything who knows the Ansible terms right there. And that's it. We don't do any updates. If you want to actually update, I would just suggest writing a small playbook or running Ansible ad hoc to do the update.
Yeah, also we discussed earlier solutions for local mirrors like Pulp and Satellite and similar tools. Those could also be used to do the patch management, and it will include not only Icinga, but probably also other packages that you have installed. Another one is for inventory management. Is there a way to work with Icinga Director and Ansible?
We have the installation for Icinga Director in the collection. We don't yet have any way to interact with it further, so we can't create hosts, we can't create services, nothing like that. If you want to do that, and I have 2 more slides, use the Icinga Director collection by Telecom MMS. It works fine. You basically just pass some information about Icinga Web, your Icinga Web user, your password, and then some information about what host or service or whatever object you want to create. I also got, if this has run through, a playbook to show that off. But yes, it's possible, not with our collection, but as I said, community is huge. Just look for it, and in this case, Telecom MMS.
Yeah, that's perfect. That closes the circle, actually, because Telecom, the folks from Telecom are also heavy Icinga and Ansible users, and they share their Ansible roles. They differ from those created by NETWAYS, because the roles shared by the Telecom folks focus on Icinga Director. So these type of setups could be done with that collection, or even in combination with the Ansible collection from NETWAYS. Can you install monitoring plugins with the Ansible tools?
Yes, there's also, let me just go to the documentation. We also have, I didn't mention it, a monitoring plugins role, specifically catered to the monitoring plugins and only that portion of the plugins, basically monitoring plugins and Nagios plugins. You can install them, and if I look down here, you basically just tell it, hey, I want to check disk, I want to check load, check SMTP or anything like that. And it has a mapping in the background to know what package it must install for that. So yeah, you can do it with this as well.
Perfect. One more question is about Icinga in general. So it's about the Icinga DB feature. They are using still Icinga IDO and want to know if that the main change between IDO and Icinga DB is the Redis in front of the backend. Yes, this is one of the major changes. In general, what we did with Icinga DB is we recreated the whole database schema that we are using to store the data, and we also changed the way how we store the data and how we process it. Basically, what Icinga DB does is it sends all the check results to Redis, but not all of the results are reflected to the MySQL or PostgreSQL database. So we are differentiating the data from which is relevant for history reasons to calculate SLAs and so on. So basically, when a state changes, it also gets updated in the database and in the relational database. But we do not store every event in the relational database anymore because it's not required. This makes Icinga Web much faster to query the data. It makes it much faster in order to store the data because we have to store less data. And in addition, we have an optimized database schema, which also helps us to keep up the performance even in very, very large environments. Also keep in mind that IDO is deprecated in the meantime and will be removed in one of the future releases of Icinga 2. All right.
Just one thing, I also want to show that actually I have my hosts right here, right now. Everything I added so far. The services have not all been checked now because the agents are not connected yet. They just need a bit more Ansible time. But okay, the up check, for example, already works, just to show you that it actually does what I told you it does.
That's perfect. So a whole Icinga master setup with satellites, Icinga for Windows, and an agent in, well, I would say less than 40 minutes. That's great. Thank you very much. All right. Since I do not see any open questions anymore that are related to today's topic, I want to give a very big thank you to Matthias because it takes a really long time to prepare these kind of things. So thank you for being with us today. Thank you for maintaining the Ansible collection for Icinga. It's much appreciated. We can also see it's much appreciated from the community as well. This is what open source is about. So thanks a lot to the folks joining us today. Thanks also to you for taking part in our webinars. We have been very successful with this format throughout the past months, and we will continue to do the webinars in this format. It works very well for us. It works very well for you. Next up in April, we will have our upcoming webinar on monitoring Windows with Icinga, a huge topic. We do have plenty of stuff in that area. Simona already shared the link in the chat. Feel free to register already so you won't miss it. Thanks for joining us today and have a great day, and make sure to tell your friends and family about Icinga. Thank you. Bye-bye.